Good afternoon. This is our Chapter 8 practice test on graphing linear functions. Let's begin. Number 1, identify the graph of h of x equals 2x squared minus 3. So what I notice about this graph, first of all, is this has been translated 3 down from the parent function. So that eliminates this answer choice. And that eliminates this answer choice. This could be an answer, this could be an answer. I do know from the a value that it's pointing up, so that doesn't narrow down. I also know from my a value that we've been vertically stretched, but I have to actually check a couple coordinates to see. So we're going to try this one first, and I'm going to try the coordinate 1 comma negative 1. So I'm going to input to my function 1 and see if the output is negative 1 to confirm that this is correct. And if it's not this one, then it must be this one. So 2 times 1 squared minus 3. 1 squared is 1, so that's 2 minus 3. H of 1 is negative 1. So this must be your answer. You could check this one as well, but if I input 2 into my function, it doesn't equal negative 1 because 1 equals the negative 1. So the one that looked stretched was actually correct. And then there's some follow-up questions to this. So the graph of H is so we have all of our answer choices here. We've already said it, that is a vertical stretch. Vertical stretch. So that's box 1. By a factor of, which is just asking what is it being stretched by. So that's just the a value. So that's by a factor of 2. So box 2 is 2. And we said it again, it's also a translation down 3. So, and it was vertical up, down. So vertical translation, 3 units. So that's box 4. And down. I would hope that if you did vertical translation, you would do up or down as your answer in that box, not left or right. On to number 2. Identify the graph of negative 1/5, g of x equals negative 1/5 x squared. So again, we're just going to see what we notice. This has not been translated. So all of these parabolas are going through the origin. The a value is negative, so they've all been reflected. So there we go. And 1/5, that means we have a vertical shrink or a vertical compression. So I'm going to find g of 1 and pick the correct graph once I know what g of 1 is. Actually, we're not going to do g of 1. We're going to do g of 2. Since this graph, they're all counting by 2s, it's going to be easier to do g of 2. So g of 2 is negative 1/5 2 squared. So g of 2 is negative 4/5. So here's 2. I would expect negative 4/5 to be somewhere around in here. So that's not close. That's not close. This maybe. And this one maybe. So we can eliminate these. Well, I'm now going to try g of 5. I probably should have done g of 5 first, to be honest. So let's do g of 5. And the reason I should have done g of 5 is simply because since this is a 1/5, it makes it evenly divisible. But More math never hurt anybody. So g of 5 is negative 1/5 times 25. So g of 5 is negative 5. So 5, no, that doesn't look right. 4, 6, 5's here. That looks like it's about negative 1.5. So here's 5, comma 5. So it's definitely this graph, not this one. So that's how you have to do these. Like, you can use the compression factor or the stretch factor to kind of start narrowing choices, but once you've kind of narrowed, you do have to evaluate the function at an input of your choosing just to see if it lines up. Well, compare to the parent function. So things that have to be included, you have to mention that it's been reflected over the x-axis. You have to mention that it's a vertical shrink or compression. You have to mention the factor. So pretty much everything that we put as a fill-in to number 1, talking about what it was, the vertical shrink or stretch, the factor. Now this wasn't translated, but it was reflected. So all of these have to be part of your sentence. You have to mention it's reflected over the x-axis. Should put that. And then it's a vertical shrink or compression, I would accept, and then the factor of the shrink. On to number 3. Okay. More of the same stuff. Identify the graph. Now this is nice. This is in vertex form. So vertex form tells us directly what the vertex is. It's the opposite of h, comma k. So the vertex for this problem is at negative 1, comma, negative 1. Well, that eliminates this answer choice. Might be this one. Eliminates this answer choice. Might be this one. So we've narrowed it down to 2. And I would hypothesize based on the A value that since this is a vertical shrink, that it's probably this one, but we're going to confirm. We're going to substitute in, let's see, we'll do P of 1 because there seems to be a point here at 1, comma 1. So we'll find P of 1 just to confirm. That's 1/2. 1 plus 1 squared minus 1. So P of 1. 1 plus 1 is 2. 2 squared is 4. Half of 4 is 2. So P of 1 is 1. That does check out. So this would be our answer choice, not this one. And then we have to fill in some qualities of the graph. So the graph of P is now this is a vertical shrink. So that's box 1. By a factor of 1/2. So that's box 2. And a translation. So we have translated, we just kind of see where the vertex moved. It's 1 unit. So 1, this is box 3. I'm just going to go look at the vertex. We went left and down. We went left and down. So left, that's box 4. And then we use, again, the 1. We have to use it twice because it's been translated 1 left, 1 down. So this is also going to be box 5. And down. Box 6. Okay. So each of those show up, and we've done a full description of how the graph has been translated. On to number 4. Good. So given a function, graphed, given a parabola graphed, domain, it has arrows. So this is all real numbers. So box 1, all real numbers. The range comes from the vertex. This is a maximum. So the highest point of this parabola is 8, and then it drops. So y is less than or equal to 8, which is one of my answer choices. So that's box 2. And then the zeros, the solutions. There's one at 3 and there's one at 7. So there's one at 3. So that's box 3. And there's one at 7. That's box 4. And we're asked to write the function in standard form. And we have some working room. So we're going to use intercept form. So f of x. Here's intercept form. X minus p, x minus q, where those are the intercepts. So f of x equals, we don't have an a value yet, x minus 3, x minus 7. Now I need to solve for a to have this done correctly. So this is where I'm going to go get the vertex as my third point to input for the x and the f of x. So the vertex is at 5, 8. So this is 8 equals a, 5 minus 3, and 5 minus 7. 8 equals a. 5 minus 3 is 2, negative 2. So 8 equals negative 4a, a equals negative 2. And that's enough to type in this in intercept form, and then we'll convert. So back up to intercept form, except now this is a negative 2. I'm going to distribute the negative 2. So I have f of x is negative 2x plus 6, x minus 7. And then we're going to FOIL this, multiply the two binomials together so we can have standard form. So f of x, first, it's negative 2x squared. Outside, that's positive 14x plus 6x minus 42, and combine the two middle terms. So your standard form is negative 2x squared plus 20x minus 42. You could have also, before distributing the negative 2, you could have multiplied these two binomials together first and then distributed the negative 2. Would have worked out the same. On to number 5. No, we have another part of this. Apologies. Letter C. So we're going to compare this to the parent function. Well, let's go look at everything that's happened here. We have a translation, 5 right, 8 up, and it is a vertical stretch with a factor of 2, and it's reflected over the x-axis. So we've got two translations, a reflection, and a stretch. So let's see if everything is there. So the graph of f is a, we have to use some context clues to know what goes in the first box. It says factor, so that's our stretch. So vertical stretch goes in box 1. By a factor of 2. So the factor that it is stretched by is always going to be a positive number. The negative tells us it's reflected. So if you notice, none of these values are negative. That's not an error. That's correct. So this is box 2. Well, translations here. So this has to be the reflection. It's a reflection in the x-axis. This is box 3. Translation. So some number of units. We'll do the x first. So 5. So that's box 4. 5 units to the right. And 8 units up. There's up. There's up. A full description of how this function is changed from the parent. Letter D. Now we're going to take the original function and do this transformation to it. So this transformation says we're going to move it 6 units to the right. So 6 to the right. So I'm going to go all the way back to my original. The easiest way to do this is just to move the vertex. So 5, 8, if I move this 6 to the right, I add 6 to the 5, and that's 11. So whichever one has a vertex of 11, 8 is going to be our answer. So let's examine 11, 8. Well, let's just double check the rest to make sure. That's 5, so that's not it. This is 11, 2. That's not it. This is 8. Nope, that's not it. It has to be this one. On to number 5. Use zeros to identify this graph. Well, to identify the zeros, I'm going to have to solve the function or convert it to intercept form, which means I'm going to have to factor it. So I'm going to come over here, and first thing I'm going to do is I'm going to factor out the GCF. So we have f of x, 2, x squared, minus 4x, plus 4. Then I factor this. What I notice here, this is a binomial squared. So this is just x minus 2 squared. So there's my intercept form, which means my 0 is at x equals 2. So this kind of sits right on top of the x-axis. So it's not this one. This has 2 zeros. This is x of 2. This is x of negative 2. And then that can't be it. So it's got to be this one. And then it asks for domain and range. Well, domain is always going to be the all real numbers as long as we have the arrows. We don't have a stopping point. So we have all real numbers. And then the range starts at, remember, y coordinate, not x coordinate, starts at 0 and goes up. So greater than or equal to 0. So y is greater than or equal to 0, box 2. To number 6. So use the zeros to identify this function. Fair enough. Well, my zeros are at negative 5 and positive 1. So negative 5, positive 1, maybe. That's negative 1, can't be that one. These are both positive, can't be that one. 1, negative 5. And our A value tells us it's been reflected. So can't be this one, has to be this. And then we're going to do domain and range again. Well, domain, we have arrows, so that's all real numbers. Range, I'm going to go up to the vertex. It appears to be at 9. So y is less than or equal to 9. So that's box 2. On to number 7. Use zeros to identify this graph. Okay, so we're going to need to factor that. I'm already starting to notice, well, one, we have a GCF here. So we're going to factor out the GCF. H of x is 4x squared minus 1. And what I notice here, one of our special cases, this is the difference of squares. So this is one of our special cases that we kind of have a little shortcut for factoring. So I'm going to square root the first term, 2x, square root the last term, square root 1 is 1, minus 1, and then 2x plus 1. And then we find the zeros. So 2x minus 1 equals 0, and 2x plus 1 equals 0. So that's 2x equals 1, 2x equals negative 1. So x is 1/2, and x is negative 1/2. Alrighty, let's go take a look. Could be this. This is 2, 1, that's a half, maybe. This is reflected, and the a value here is positive, so it can't be that one. This doesn't have 2 zeros, and this doesn't have 2 zeros. It has to be this one. And again, we're asked for domain and range. We have arrows, so all real numbers. And we can go to the graph. Looks like the vertex here is at -4. So y is going to be greater than, because it's pointing up, or equal to the -4, which is this box. Goes there. On to number 8. All right, we have to determine whether the table represents linear, exponential, or quadratic. First thing I'm going to check is if I have a constant rate of change or a common ratio, because that's the easiest to see. All right, 4 to 8, that's an increase of 4, or it's multiplying by 2. 8 to 16, well, that's multiplying by 2. So this is times 2. That's times 2. 16 times 2 is 32, and 30